Welcome back to the Deep Dive. Today we are wrestling with what's arguably the toughest problem in physics, unification. For ages we've had these two incredible theories, quantum mechanics for the tiny stuff, general relativity for gravity, and the big picture.
But they just don't talk to each other.
Yeah.
Fundamentally incompatible languages, mathematically speaking.
Exactly. Okay, let's unpack this. Our source material for this deep dive, it takes a really radical approach. It argues we don't just translate between QM and GR. You need to, scrap the foundations and start over. They're proposing this thing called the Finsler Coherence Hyperfractal Phase Space, FCHP for short.
Yeah, and FCHP, it's a total reframing. It says the bedrock of reality isn't particles, it isn't fields in space. It's something they call the coherence vacuum. They use the symbol $. For it.
The coherence vacuum. $. So that's the starting point for everything.
That's the idea. Our mission today, really, is to dig deep into the principles of this theory. We need to figure out how FCHP actually defines this primordial stuff, this vacuum.
Right. And how things like quantum effects, discreteness and relativistic geometry, how they emerge from it.
Exactly. And maybe the craziest part is how it redefines forces, mass, gravity. They aren't fundamental interactions in the usual sense, but properties of the space itself.
Okay, so if there's one takeaway for you listening, it's probably this core axiom they put forward. Coherence is primordial reality.
It's the substance. It's not just a property of waves or particles.
No, it comes before all that. Before anything we could observe, it's like the fundamental grain of the universe.
That's the foundational claim, yeah. So let's start right there with that primordial substrate, the coherence vacuum, zeta dollars and hours. When the sources define FCHP, the term they use is hyperfractal manifold.
Okay, hyperfractal manifold. That doesn't sound like Einstein's smooth, passive spacetime at all.
Not even close. That phrase immediately suggests, infinite complexity, layers within layers, self-similarity.
Right, and the sources describe it as a space of, infinite potential, but it's not just empty potential. It's already structured.
Inherently structured by specific geometric things. Chirality, torsion, nested dimensions.
So before any observer, before anything exists, the space itself has preferences, built-in twists and turns.
Precisely. It's geometrically active from the get-go. And that inherent structure, that's the key, they argue, to unification.
How so?
Well, the FCHP model says everything we experience, particles, forces, fields, even the curvature of spacetime, they're all just expressions of something called coherence reductions.
Coherence reductions. Okay, but wait, if the starting point is this pristine coherence vacuum, why does the universe we see look so messy, so incoherent, relatively speaking? Where did coherence go?
That's the crucial point. The messiness is the expression. It's not that coherence is lost, it's that it's reduced. The sources describe these reductions as specific stable states or eigenvalue thresholds that the hyperfractal manifold can sort of settle into.
Okay, the manifold is this super complex system, maybe digital-like, and the reductions are specific modes or outputs it can run.
That's a good analogy. The universe, as we experience it, is basically running a set of these reduced stable coherence modes. It's a lower energy stable configuration of the original potential.
Wow. Okay, that completely changes how we think about field theory then. If forces aren't external things in space.
Right.
But they are space, just in a specific mode. The electromagnetic force is just space operating under one kind of coherence reduction.
That's the claim. The source material is very clear. Forces are reframed as space properties. They're not grafted onto space. They are expressions of the space's own internal geometry and dynamics.
That's a much more economical picture, conceptually at least.
It aims to be. And we can actually map this onto the standard model's gauge symmetries, U1, SU2, SU3.
Which we normally think of as the rules for forces, right? Conservation laws.
Exactly. But in FCHP, they're recontextualized. They become specific eigenvalue thresholds of coherence. They represent different stable geometric configurations within the FCHP structure.
So the familiar symmetries are just different ways the coherence vacuum can express itself once it undergoes reduction. Let's break that down. What's the mapping?
Okay, let's start with U1 symmetry. Usually that's electromagnetism.
Right. Like charge.
In FCHP, U1 is seen as representing minimal torsional symmetry. Geometrically, torsion is about twisting or non-flatness in the manifold.
A twist in space.
Yeah, a fundamental twist. The U1 reduction is linked to the simplest possible twist, like a basic phase relationship or a dispersion effect in this coherence stuff. Think of it as the minimal single-axis twist the system can maintain. It defines things like wave phase.
And that simple twist is what we experience as electromagnetism.
That's the interpretation, the simplest geometric expression of coherence flow. Then we get to SU2 symmetry. That's the weak nuclear force. And here, the geometry gets really, really critical. SU2 represents chirality symmetry.
Chirality, handedness, left versus right. Why is that so fundamental here?
Because the source material calls the breaking of this symmetry, establishing that left-right distinction, the seed of mass.
The seed of mass. So mass originates from a fundamental handedness in space itself.
That's the radical claim. It's not just a quantum rule. It's built into the geometry of the coherence vacuum from the start. This fundamental handedness dictates how things interact with the vacuum. Processes governed by SU2, like parity violation, are tied directly to this geometric feature.
I see. So if you have handedness built into space, you automatically have a way to define directional interactions, which you need for mass.
Precisely. And if that seed is geometric, baked into the vacuum,
then you don't necessarily need a separate Higgs field to give things mass, at least not at the most fundamental level.
Wow. That is a huge conceptual leap.
It's a massive simplification if it holds up. It makes mass an emergent property of the geometry.
Okay. And the last one, SU3, symmetry. The strong force color charge.
Right. In FCHP, this is the most complex reduction. It represents complex torsional binding.
Complex torsional binding. So the strong force is basically just a really intense, tangled knot in the fabric of space itself. That's a good way to visualize it, yeah. Because the strong force is so incredibly powerful, the interpretation is that it generates this color-like coherence. It manifests as multi-axial distributed twisting within the manifold.
So not just a simple U1 twist, but like braiding multiple strands together.
Exactly. A complex, tangled knot of coherence flow. That creates immense tension, requires huge energy to break, reflecting the strength of the nuclear binding force. So all three symmetries, U1, SU2, SU3, they become geometric properties. Simple torsion, chirality or handedness, and complex torsion, distinguished by the complexity of the twists and turns in the coherence vacuum. Now, if you're going to reframe forces like this as just expressions of a dynamic structured vacuum, well, you need a new kind of geometry. You can't use the standard Riemannian geometry that underlies general relativity.
Because Riemannian geometry assumes space is, well, basically the same everywhere in every direction. Isotropic, passive.
Exactly. It's too smooth, too simple. It doesn't have the built-in structure FCHP needs.
Okay. If we connect this to the bigger picture, this requires a radical new geometry, which leads us to Finsler geometry. For listeners maybe not familiar, what's the key thing about Finsler geometry?
The absolute key is anisotropy. Its metrics, the way it measures distance, depend on direction.
Like walking through a dense forest versus an open field? The effort, the distance covered effectively, depends on which way you go.
That's a great analogy. Or think of moving through a strong magnetic field or a crystal lattice. Direction matters. In Finsler space, the ruler changes depending on which way you point it and the paths you take.
Which sounds exactly like what FCHP needs, right? If space has inherent twists, torsion, and handedness, chirality.
Precisely. Movement through that kind of space must be direction dependent. Finsler geometry naturally handles this. It also incorporates things like non-metricity rules about distance preservation being relaxed, and it naturally includes torsion and curvature anisotropy.
So it's the mathematical toolkit for a space that's alive and structured.
You could say that. It's designed for spaces where direction fundamentally matters.
Okay, let's dig into those two geometric properties again, chirality and torsion. How are they really built in to this coherence vacuum?
Okay, chirality again linked to SU2. The sources are specific. This handedness is part of the very geodesic framing of space. Imagine trying to draw a perfectly straight line. In this FCHP space, the path your straight line takes is already subtly influenced, pre-biased, towards a left or right twist.
So the straightest path isn't straight in the Euclidean sense. It has an inherent curve.
A chiral curve, yeah. That built-in preference, that geometric handedness, is framed as the foundational mechanism that allows mass to emerge. It is the geometric template for the weak interaction.
And then torsion, linked to U1 and SU3. You mentioned simple versus complex twist. Can you elaborate on that distinction?
Sure. Torsion is about the local twists. The complexity of the twist determines the resulting force. For U1, think simple, single-phase twists, like a gentle ripple, maybe a slight shear stress in the coherence flow, relatively easy to create and sustain. But for SU3, it's complex, multi-axial distributed torsion. Go back to the knot analogy. Not just a simple overhand knot, but a complex braid using multiple strands twisted around each other in intricate ways.
Ah, I see. Much harder to tie, much harder to untie.
Exactly. It holds immense tension, embodies more complex geometric information, and requires more energy reflecting the strength of the strong nuclear force holding quarks together.
This whole geometric setup leads to that really revolutionary idea you mentioned, mass without Higgs. If SU2 chirality provides the seed, where does the actual amount of mass, the value for different particles, come from?
According to FCHP, mass emerges quantitatively when coherence gradients cross certain thresholds. Specifically, when the local density of chirality may be combined with torsional stress hits a specific, predetermined eigenvalue.
Eigenvalue, like a specific resonant frequency or energy level of the vacuum itself.
Exactly. Think of the vacuum having these allowed stable energy states. When a disturbance, a concentration of coherence gradient, reaches the energy level corresponding to one of these eigenvalues, poof, mass appears. The transition across that threshold is the mass event.
So instead of a separate field, the Higgs field, acting like cosmic molasses, mass is just a measure of how strongly something couples to or maybe resonates with the inherent chiral structure of the vacuum at a specific quantized energy level.
That's the core concept. It shifts the whole mechanism. It's not an external interaction. It's an emergent property of the coherence reduction hierarchy itself. It replaces the need for a separate scalar field with essentially a geometric phase transition.
Elegant, if true, but incredibly complex geometry. Okay, so if this intricate direction-dependent geometry is dictating mass at the quantum level, how does it handle the big stuff? General relativity, gravity itself. Let's start with basics. Things like time dilation, length interaction. How does FCHP reinterpret those?
Well, traditionally in GR, mass warps spacetime, and that geometric warping causes those effects. Simple as that, conceptually.
Right. Curved geometry dictates motion and measurement.
FCHP flips the script slightly. It suggests these effects are better understood not just as geometric warping, but as coherence coupling constraints.
Coherence coupling constraints. Okay, that sounds a bit abstract. Can you make that more tangible? What does that mean, experiencing a constraint?
Okay, imagine again you're moving through that resonant jelly, the coherence vacuums that have dollars. As you accelerate, you're pushing through progressively denser or maybe more structured or more directionally resistant parts of this medium.
Right. The resistance changes based on speed and direction through the vacuum's structure.
Exactly. The difficulty in maintaining your own internal coherence, or maybe just the increasing interaction strength with the vacuum structure as you accelerate. These physical constraints imposed by the dense anisotropic medium you're moving through, those are what manifest geometrically as time slowing down relative to a stationary observer, or distances appearing contracted. Ah, okay. So the geometric effects, time dilation, length contraction, even light bending, they're like the symptoms of interacting more strongly with the underlying coherence structure. The fundamental cause is the changing coherence coupling strength.
You got it. The geometric warping is the observed effect, the consequence, not the primary cause. The cause is the interaction with the structured vacuum.
Which then leads us to gravity itself. The FCHP model defines it using this term, hypergravity invariance. What's the core idea there?
It's a pretty profound reorganization. Gravity is redefined. It's no longer just space-time curvature caused by mass. Instead, it's framed as the interaction between the overall global coherence field tensor, the state of zeta dollars across the entire universe, and local distributions of matter and resonance.
Okay, so say a star forms. That's a huge concentration of matter, meaning a lot of cross-chirality thresholds, intense local coherence gradients.
Right.
That concentration locally disturbs or changes the structure of the universal coherence field in its vicinity? Precisely. That local perturbation, the change in coherence density, the induced geometric stress from all that concentrated chirality and torsion, that's what produces the macroscopic space-time curvature that we measure and call gravity.
And the hypergravity invariance part, what does that imply?
It suggests that the fundamental mathematical principle governing this interaction between the local and the global coherence state remains the same, remains invariant, across all the nested layer or scales of this proposed hyperfractal manifold. So There's a consistent underlying law, even if its geometric expression looks different depending on the local coherence density or the scale you're observing.
Mm. It sounds incredibly complex mathematically. Is the argument that FCHP, despite using this more complicated Finsler geometry, is somehow simpler overall than having both GR and the standard model as separate things?
That's definitely the hope, and it's a critical question for the formalization roadmap we'll get to. The theory aims for ontological economy, fewer fundamental things in the universe, just the coherence vacuum in its states. But yes, the required mathematical framework, Finsler geometry, is undeniably more complex than Riemannian geometry.
So the bet is that the complexity of the geometry naturally gives rise to all the forces and particles, making the whole system more unified and ultimately more elegant than our current patchwork.
That's the bet, that the right starting point, the right action functional within this geometry will elegantly generate everything else, justifying the initial geometric complexity.
Okay, so just to button up this section, the connection between the geometry, Finsler non-metricity, torsion, chirality, and gravity is?
The geometry is the mechanism. Matter and resonance are just specific patterns of coherence, gradients, concentrated chirality, twisted torsion. The anisotropic, non-metric nature of Finsler geometry is what allows these local patterns to translate directly into changes in the surrounding space's structure, which we then measure as macroscopic curvature or gravity. It provides the language for how local coherence changes affect the global field.
All right. Any theory claiming to unify physics, especially one this radical, has got to give us something concrete, testable predictions. The sources suggest FCHP isn't just, abstract math. It might connect to things scientists are already looking at.
Yeah, they try to map it onto current research, suggesting we might already be seeing faint signals of this underlying structure.
Okay, like what?
Well, the first obvious place is Finsler spacetime research. Since the whole theory requires this anisotropic geometry, any research looking for evidence of direction dependence in spacetime is directly relevant.
And people are actually looking for that.
Oh, yes. There's ongoing work looking for subtle Lorentz violation. That means violations of the principle that the laws of physics look the same no matter how you're moving steadily. FCHP predicts violations at some level because direction matters. They also look for modified dispersion relations.
Meaning light of different colors or particles might travel at infinitesimally different speeds depending on their energy or direction through this structured vacuum.
Exactly. So astronomers and physicists are looking very carefully for tiny, direction-dependent cosmological effects. Does the speed of light really seem constant in all directions? Do fundamental constants appear slightly different if measured along different cosmic axes? Any confirmed anisotropy like that would be potential evidence for an underlying FCHP-like structure.
Okay, interesting. What else? You mentioned a link to biology.
Yeah, this one's quite provocative. It connects to quantum coherence in biology. We know from experiments with things like Bose-Einstein condensates or in quantum optics that coherence can be maintained for measurable time.
Right. But in messy, warm, wet biology.
Well, the focus here is on structured water, sometimes called exclusion zone or EZ water. Experiments suggest that water near certain surfaces can form highly ordered, crystal-like layers that can support quantum coherence effects for surprisingly long times.
Structured water.
Huh.
Okay. How does FCHP interpret that?
In FCHP terms, these ordered water structures are potentially aquashell coherence engines. The idea is that these biological structures might be uniquely capable of tapping into, stabilizing, and utilizing the fundamental coherence of the $0 vacuum.
Whoa. So life isn't just happening in the vacuum. It's actively using the vacuum's coherence properties. Water becomes like an interface.
That's the implication, a physical mediator between the biological system and the fundamental coherence substrate. It suggests life might leverage these universal dynamics directly for its processes.
While, okay, scaling back out, what about cosmology? The big picture stuff.
They look at the large-scale structure of the universe. You know, the cosmic web, those vast filaments of galaxies separated by giant voids.
Which we usually explain with gravity, right? Dark matter clumping under gravity, pulling normal matter along with it into these filaments.
That's the standard model, yes. FCHP offers a complementary or perhaps deeper perspective. It suggests these filaments might actually reflect coherence corridors within the $0 vacuum itself.
Coherence corridors, like channels or slow lines in the vacuum structure that guide expansion.
Kind of. The idea is that the universe's expansion wasn't perfectly uniform or isotropic. It was guided and shaped by the intrinsic chiral and torsional structures within the coherence vacuum. These structures acted like a kind of cosmic scaffolding, directing where matter would preferentially congregate. So the filaments might be tracing the underlying geometry of the vacuum's coherence flow.
So structure arises from the vacuum's inherent structure, not just from gravity acting on initial random fluctuations.
It could be a combination, but yes, it gives the vacuum a much more active role in shaping structure. And if FCHP can explain the visible structure...
It also needs to tackle the invisible stuff, dark matter and dark energy.
Right. And here, FCHP tries to internalize them. They're not seen as separate exotic particles or fields, but as intrinsic aspects of the FCHP structure itself.
How? What are they in this model?
Dark energy, the accelerating expansion, could be related to regions of coherent slack. Think of it as potential energy stored in the hyperfractal layers of zettadollars that haven't fully reduced or coupled into our observable four-dimensional reality yet. It's like latent geometric tension driving expansion.
Okay, potential energy in the vacuum structure and dark matter.
Dark matter could correspond to stable, localized configurations within the FCHP geometry that don't interact electromagnetically. Maybe highly localized regions of torsional mode misalignment or specific chiral densities that are stable but only couple significantly via gravity because their coherent state prevents other interactions. Geometric knots that only interact gravitationally.
Fascinating. So the dark sector isn't other stuff added on, it's just parts of the coherence vacuum behaving differently or parts we don't fully interact with.
That's the elegant proposal. It simplifies the ontology, fewer fundamental ingredients, but again, relies on that complex geometry.
Right, which brings us to the really crucial part, the specific make-or-break predictions, the things we could actually measure to see if this whole idea holds water.
Exactly. This is where the theory has to deliver. Prediction 1 is directional variation. This flows directly from the core idea of Finsler geometry.
Test the anisotropy.
Precisely. Look for tiny but persistent directional variations in fundamental constants. Is the electron's mass exactly the same when measured relative to galaxy movement in different directions? Is the speed of light truly absolutely constant regardless of the direction of travel across cosmological distances?
What kind of observations would show that?
Highly precise tests of isotropy. Looking for something called cosmic birefringence, does the polarization of light from very distant quasars get rotated slightly as it travels through space, and does that rotation depend on direction? Analyzing redshift patterns for anisotropy, do galaxies at the same distance show slightly different redshifts depending on their position in the sky relative to some cosmic axis? Finding any confirmed systematic directional dependence would be huge support for FCHP.
Okay, that's cosmology. What about particle physics? Prediction 2, quantized mass thresholds.
Yeah, this goes back to mass emerging at specific coherence eigenvalues. If that's true, then mass generation shouldn't be perfectly smooth.
What does that mean in practice?
It means in high-energy particle collisions, where particles are created, or in precise measurements of particle decays, we should look for evidence that mass appears in discrete stepped increments. Not just any value is allowed, but specific quantized thresholds are crossed. It would suggest mass arises from hitting these specific resonance levels within the vacuum structure, matching the predicted coherence eigenvalues.
So looking for deviations from the standard model and how mass manifests, specifically looking for quantization steps.
Exactly. Beyond just finding new particles, looking at the process of mass formation itself for signs of these discrete thresholds.
And finally, back to biology and maybe the most out there one. Prediction 3, biological coherence memory.
Right. This connects the physics directly to the observer, or at least to complex biological systems. It calls for really deep investigation into coherence times within those proposed aquagel coherence engines, structured water, microtubules in neurons, etc.
And what's a specific thing to measure? The observable signature?
The prediction is a correlation between the measured duration of biological coherence, how long these systems can maintain an ordered quantum state, and the reported intensity or clarity of subjective experience, or qualia.
Wow. So you're suggesting measuring how long, say, microtubules stay coherent and comparing that to someone's reported subjective perception.
That's the deeply provocative link the sources suggest exploring. If consciousness is somehow related to accessing or interacting with this fundamental coherent substrate via biological mechanisms, then maybe the quality of that interaction reflected in measurable coherence time correlates with the quality of subjective experience. It's trying to build a physical bridge between coherence physics and consciousness. A very tall order experimentally.
Understatement of the year. But definitely a discriminate prediction. Okay, whether FCHP turns out to be right, wrong, or somewhere in between. Just thinking about it forces a huge ontological shift. It really changes the way you think about what is.
Absolutely. It's a profound shift. You move away from an ontology of, well, stuff, particles, fields, objects, and the relations between them.
Right, the billiard ball universe, essentially, even at the quantum field level.
And you move towards an ontology where the primary reality is coherence, states, resonance, and thresholds. The universe becomes this dynamic, resonant, geometric structure, expressing itself in different modes, different layers of reduction.
And the huge philosophical takeaway is that space isn't the stage, it's part of the play. It's active, structured. Forces aren't external actors, they're just modes of the stage itself. Geometric expressions of coherence.
No separate force fields disconnected from the geometry of space. That's a core tenet.
Which also seems to lead towards this idea of a participatory reality.
Because in the FCHP framework, the observer, or really any localized system capable of maintaining coherence, like a biological organism or even a measurement device, isn't truly separate from the fundamental coherence, zeta dollars, or the space it structures.
They co-emerge.
They co-emerge within the FCHP structure. Observation isn't just a passive reading taken from outside. It's framed as an interactive process within this coherence hierarchy. The act of measurement, or even conscious observation, necessarily involves coupling with the coherence vacuum and potentially influencing the specific reduction state being observed.
Okay, that starts sounding very philosophical, almost mystical. But the sources insist this is meant to be rigorous science. Which brings us to the formalization roadmap. How do they propose turning this grand vision into actual testable mathematics?
It's incredibly ambitious, obviously. They lay out a kind of three-step plan to try and build this from the ground up mathematically.
The step one.
Step one, the action functional. Like any fundamental theory in physics, it has to start with an action principle. This is the mathematical expression that, when minimized, gives you the laws of motion and the field equations. They need to find a single coherence invariant action functional.
A coherence invariant, meaning the fundamental mathematical description of the universe looks the same, regardless of which coherence state or reduction level you're looking at.
That's the goal. Find the single master equation that holds true across all layers of the FCHP. Then the absolute critical part is mathematically analyzing the symmetry breaking points of this functional.
Ah, the points where the unified symmetry breaks down into the specific forces we see.
Exactly. Those symmetry breaking points must precisely correspond to the proposed coherence eigenvalues that generate the gauge symmetries U1, SU2, SU3. Finding that functional and showing it breaks correctly is, well, that's the holy grail right there. Monumental task.
Okay. If they can find that functional, what's step two?
Step two is rigorously applying the geometry. They have to actually use generalized Finsler geometry to model the space described by the action functional. This is the heavy mathematical lifting.
This is where they connect the geometry features to the physics.
Precisely. They need to formally mathematically map the geometric property of chirality to the operators, the generators of the SU2 symmetry group. They need to map the different types of torsion simple and complex rigorously to the generators of U1 and SU3. This step is about proving that the FCHP geometry, driven by that action functional, can mathematically generate the forces of the standard model purely from its internal structure.
Okay, find the action, map the geometry. Step three must be connecting it back to known physics.
Yes. Step three, modified field equations, the ultimate proof of concept. They need to derive entirely new field equations from their action and geometry. These equations must explicitly include coherence threshold operators, mathematical terms that dictate where and how the coherence reductions happen, how the symmetries break.
So, new equations incorporating the FCHP machinery.
Right. But crucially, these new, more complex equations have to be shown to reduce back to the equations we already know and trust in the right circumstances.
Meaning they have to become Maxwell's equations for electromagnetism, Yang-Mills for nuclear forces, and general relativity for gravity when you look at the right scales or in the right limits.
Exactly. When coherence is assumed to be uniform, or when you average over quantum effects or look at low energies, the FCHP equations must simplify back to the physics we use every day. If they can achieve that, derive new equations with coherence operators that correctly reduce to known physics, then they've essentially formalized a unified theory based on FCHP principles.
Just listening to that roadmap The sheer intellectual ambition is kind of mind-boggling. It's not just tweaking existing theories. It's a complete rebuild from the axioms up.
It really is. It requires physicists to fundamentally shift their perspective, to see the universe not as a container with things in it, but as a single, dynamic, resonant, geometric entity. Hashtag, tag out your reference.
So we've journeyed through the intricate landscape of the Finsler Coherence Hyperfractal phase space. So what does this all mean? Well, for you trying to make sense of the frontiers of physics, it suggests that maybe, just maybe, the path to unification requires embracing a much weirder kind of geometry. Finsler geometry, direction-dependent, fundamentally chiral, inherently twisted. It means thinking of space not as empty or passive, but, as the sources put it, alive with resonance, thresholds, chirality, and torsion.
Yeah, the discreteness we see in quantum mechanics, the smooth geometry of relativity. In this view, they're just different emergent layers, different expressions of this single underlying coherence vacuum, Sato dollars.
The big takeaway seems to be this potential for elegance, right? Getting rid of separate forces, separate fields, and saying it's all just different ways the geometry resonates.
If it works, yes. It's an incredibly economical concept in terms of fundamental entities, even if the mathematics gets significantly more complex initially.
And as we wrap up this deep dive, let's circle back one last time to that really provocative edge of this model, the potential link between fundamental physics and biology, even consciousness.
Right, that prediction 3.
Yeah. Given that proposed connection between structured water, coherence memory, and perception, and the core idea that mass and force are just expressions of coherence thresholds, what does that imply about the physical nature of thought itself?
It's a question that pushes boundaries.
If these biological coherence engines, as they call them, can genuinely access or interact with these fundamental layers of the coherence vacuum, does that imply that the act of observation, maybe even subjective awareness, is somehow entangled with the very physics that generates mass and gravity within the FCHP structure?
The implication is that mind might not just be observing reality's structure, but might be participating in some way in its very manifestation at the coherence level.
A pretty mind-ending thought to leave you with. It really blurs the line between observer and observed, mind and matter, at the deepest possible level. If we could truly understand biological coherence, maybe we'd unlock something fundamental about the cosmos itself.
A radical possibility indeed. Thank you for joining us for this deep dive into a very different way of looking at the universe.